Hmm. So we're discussing esters today. Now, in this esters unit, children face different kinds of problem. Some children are not able to identify what an ester is. If a structure is given to them, they're not able to identify which is an ester, which is a carboxylic acid. So they're often confused whether it is carboxylic acid or whether it is an ester. So that is the confusion. Some children are not able to draw the structure of the ester. Let's say the examiner is saying that you have this particular acid and it is reacting with this particular alcohol. You tell me the structure of the ester and the name of the ester. So some children struggle with this. Sometimes we have these kind of questions where the ester is given, but the examiner is asking what is the acid plus the alcohol this ester is made out of. It must be made out of some specific acid, some alcohol, right? So they ask you the other way around as well. Sometimes it is acid plus alcohol giving ester. They can ask you the name of this ester as well as the structure. But they can also flip it. They can give you the ester and then they can ask you what is the alcohol and what is the acid. So we will discuss all kind of problems in detail for esterification reactions today. Let's start with a few basic things first. I'll show you a few different kinds of questions and we will discuss the theory. After that, we will discuss these questions. Now, if you read this question carefully, they are just saying that ethanol reacts with methanoic acid to form ester. Name the ester and draw the structure. So it's like your typical ester question where acid is given and the alcohol is given. They're asking you to name the ester and also the structure of the ester. We'll see. For now, I'm just showing you the different kind of questions IGCSE asks you. Alright, now there is another question and it's a question of different topics, but if you look at part 5, the part 5, we can zoom in. This is not zoomed in. I think this is good enough. Yeah. So give the letters of the two compounds that can react with each other to form ester. So give the letters of two compounds out of all of these which can react together to form an ester. And you know that it's going to be acid and alcohol, right? So this kind of question is generally asked. Then see here they have given you the structure of ester and they're asking you to name the ester. And then the reverse question they're also asking you that now from this ester, tell me which acid was used to create this and which alcohol was used to create this. So they're saying give the name of the alcohol and the acid. So the same thing they can ask you question in any way. You need to understand this conceptually. Another question, the formula is given of the ester. They're asking you to name it and name the carboxylic acid and alcohol. We will discuss. Just another question, they're saying that draw the structure of carboxylic acid and ester which contain two carbon atoms. You have to draw the structure of both of them. Alright, so this was just to help you understand what kind of questions IGCSE will ask you on esters. It's different kinds of questions. Let's start with a theory now. First things first, let's start with a theory. And I think most of you will be feeling something like this that yes, alkanes is very easy. Alkenes is also recent. Alcohols, then the OH comes in, carboxylic acid, COOH. And most of the students struggle with esters. Now, we are starting with esters and first what we need to do is, we need to learn to identify ester. Naming how to draw ester, we will discuss, but you first of all need to identify ester and differentiate it from carboxylic acid. Children often confused carboxylic acid with ester. Alright, so let's discuss this first. See, carboxylic acid is COOH, or you must have seen this written like this, COOH. Now, you need to understand one thing. If it is a carboxylic acid, it will always be present on the terminals of the chain. This carboxylic acid cannot be present in the middle, something like this. This is not possible because it can form only one bond. Hydrogen is already stable. So very clear difference is there. Carbon cannot be present in the middle of the chain. We can write it down here. Middle of the chain. Not carbon, sorry. Carboxylic acid cannot be present because it can create only one bond. And for a molecule to exist in the middle of the chain, it needs to create bond from two sides, right? So that is not possible. But if you look at ester, ester is a little different. Ester is something like this. Now see, notice the difference. This is carboxylic acid and the top is ester. Now ester has two bonds free, one on the left and one on the right. That means ester will only be present in middle of the chain. It cannot be present on the terminals. So I'm hoping this clears the confusion of carboxylic and ester. I'm just summarizing this again. Ester bonds from both sides, left as well as right. So it cannot be present on the terminals of the chain. Extreme left, extreme right, it's not possible because it needs to be present in the between. Then on the other hand, carboxylic acid looks a little similar to ester, but it also has an additional hydrogen and it can only bond from one side. So carboxylic acid cannot be present in middle of the chain. It will always be in terminals. By terminals I mean extreme left hand side of the chain or the right hand side of the chain. Alright, now I'm hoping this confusion is clear. Let's draw a few different structures and let's see if we can identify which one is an ester, which one is an carboxylic acid. So see, just a minute, I think I have drawn a few structures in the previous pages. Yes, here are these. Now, just identify this. This is COO present and it is present somewhere around in the middle of the chain. Carboxylic is COOH. Second thing that COOH cannot be present inside the middle of the chain. So this is your ester. Identification done. Now, this is written in a little different way, but you need to understand these are in reality 3D molecules. So it really doesn't matter whether you are drawing it upwards or downwards. Alright. But as you again can see, there's a bond, then there is a carbon, double bond oxygen, then bond another side. That means it is bonded from both sides, it will be an ester. In this one again, you can see COO is there, not COOH. So this is an ester. Now, sometimes they condense the formula and they write it in this format. Then, often a lot of children get confused that how do I draw this? See, you can start one by one. Look at this carbon, pay attention to this carbon, we can zoom it in. Pay attention to this carbon. This is connected to 3 hydrogens. So 1, 2, 3. Then it must be connected with a second carbon, right? This one. We can name this second, first, third, fourth, sixth. Now this carbon has 2 hydrogen on top of it. Then this carbon is connected to COO. Again, you need to understand carboxylic acid is COOH and it cannot be present in the middle of the chain. So this is directly telling me this is also an ester. C double bond O, then single bond to O, then C, then C, then C. You can put your hydrogens there. I'm a little lazy, so I'll just put dash. Alright, so sometimes in condensed form it can be also written like this. But again the same thing, if COO is written anywhere in the middle of the chain, not the terminals, then it will always be an ester. Alright, another example. See this one, I think we can fairly easily identify now that it is in the middle of the chain somewhere. It is connected to both ends, right, of the carbons. So this is an ester. Again, this is an ester. Alright, now, so identification wise, you can write ester like this. C double bond O, then one bond here, one bond here. Or if you're condensing it, you can write it like this, dash COO dash. Sometimes in some sources that you study from online, you might see representation like this. Now some children get confused, what does this R mean? This R means any carbon chain. Alright, it could be 5 carbons, 6 carbons, 7 carbons. And this R dash means any different carbon chain. Do not worry, they will not ask you what is the chain here. This is just representation wise. Alright, and if you condense this, then you can write R here, and CO. Got it? Now, I'm hoping identification wise everyone is clear with this. Now, let's actually start how esterification is done. Just a minute. So let's start with the actual esterification reaction now. The general idea is that when carboxylic acid reacts with an alcohol, then the product form is ester plus one molecule of H2 is formed. But how exactly do we form the product? How exactly do we name the ester? There are lots of things. So first we are going to understand how to name the ester without drawing the structure of it. Alright. So for this I have one small point for you, or you could say a small trick that will help you name the esters without having to draw the structure. Sometimes the examiner will directly say that let's say we have ethanoic acid, and this ethanoic acid is combining with propanol. What is the name of the ester? Now, there is one way that you try to draw the structure and then you try to name the ester. This is going to take a lot of time, and usually these questions are 1 mark where they give you the acid and the alcohol and they ask you to name the ester. So there is an alternate way. The alternate is that the alcohol that is given to you, right? So it will act as a prefix. Let's say, for example, methanol is given, so you will call it methyl, methyl, or let's say if propanol is given, you will call it propyl. And in the suffix, the acid will act. Again, for example, let's say methanoic acid is given to you. So in the ester, it will be called methanoate. If pentanoic acid is given to you, an acid with 5 carbons, you will call it pentanoate. What is the trick here? That without having to draw the structure, you can directly name the ester. How exactly? The alcohol that is given to you, you will write that but with YL, Y-L-E, YL, sorry. So methanol will be methyl, propanol will be propyl. Then what will be the suffix? The acid will give you the suffix O8. Now, not so clear. Let's try some examples, then it will become very easy for you. We can pick, let's say, 5 examples. For example, let's say propanol and methanoic acid is given to you. So, without drawing the structure, how do you name this? Propanol will be called propyl and methanoic acid will be called methanoate. This is the name of your ester. Another example, butanol plus ethanoic acid. Again, the same point that butanol will be written as butyl and ethanoic will be written as ethanoate. Another example, let's say methanol is given plus, which one should we use? Let's do pentanoic acid. So this will be called methyl pentanoate. Alright. So you need to understand that alcohol will be written as YL and the acid will give you O8. Got it? Let's pick another example. We can say ethanol plus ethanoic acid. So we will call this ethyl ethanoate. Alright, so I'm hoping the naming of esters is clear to you. We have only discussed the naming and the basics of naming. We haven't discussed the structure and deducing the name from the structure. This we have not discussed yet. So I'm hoping that Naming basic is clear to all of you. Now, how exactly do we draw the structure? Let's start with that. See. Now, for drawing the structure, I have one small trick for you or one small point that will help you avoid any mistakes in the future. You should write the acid first and then the alcohol. For example, let's take a few examples. Acid, we can pick ethanoic acid, so CH3COH. Alcohol we can take as, let's say, propanol, so propanol. So propanol is CH3, CH2, CH2OH. Now, how exactly do we draw the structure? There is one thing you need to keep in mind, that you will write the acid in regular format, but alcohol you will write in the twisted manner. What do I mean by twisted manner? Something like this, that OH should be to the left, OH should be closer to the acid, then your CH2, then your CH2, then your CH3. Alright. Now you might be thinking, what is the benefit of doing this? See, I'll show you. Now for propanol, instead of writing it like this, we will write it the other way around. I will take OH to the left hand side, then carbon, carbon, carbon. Hydrogens, I'm just putting a dash. Again, I'm a lazy person. So like this. Now, what is the benefit of writing like this? The benefit is that you can directly circle out H2O from here. See, you can directly circle out H2O, right? And if you're thinking that do I always have to pick the H from acid and OH from here? No, it doesn't matter. You can also pick the OH from acid and H from here. But generally it's said that acids release H plus ions, so you should do it this way. You should cut out this section. Now, see, we will cut out this section and in the products, one molecule of H2O will be formed, right? Now, this oxygen that is present here, this oxygen will directly combine with this carbon because the atoms present in between both of them, now they are gone. So, oxygen will directly bond with the carbon. You have to draw everything as it is. See, carbon, C double bond O. I've drawn everything as it is, but now this H and OH, they are gone from here. So the oxygen here will directly combine with the carbon. Done. This is your ester. What did we do here? We wrote down the alcohol in the other way around manner, simply meaning that alcohol written closer to the acid. Why? Just to show you directly so that you can also understand how H2O is formed as a product. You can circle this out. These two react with each other and form H2O as a separate product. But now, what about the ester? If this is all gone, H and OH is gone, so this oxygen present here, it will combine with the carbon directly. And you can see here, I've done the same thing. This is your ester. Let's do another example. Let's pick butanoic acid with methanol. So, we will draw butanoic acid in the regular manner. 4 carbons, then O, OH, hydrogen, 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 hydrogen. Now, alcohol we will again try to draw so that OH is towards the left, closer to the acid, and this is your methanol. I'm not drawing the hydrogens. Now, what do? You can again cut out this H and OH. They are cut out now. So, in your product, you will have H2O and this oxygen now will directly bond with the carbon because everything that was present in between them, that has been subtracted as another product, right? So now this oxygen will bond with this carbon. I'm hoping this makes sense. So again the same thing, we will draw everything as it is. C double bond O, then oxygen. Now this oxygen will combine to the carbon of the alcohol. This is your ester. Alright, so some children face confusion and understanding, or they're directly not able to see from the equation how H2O is forming as a product. For that, I've asked you to use this method, that alcohol you should write in such a way so that OH is closer to the acid. Why? Because here you can directly see that OH is combining with this hydrogen. So this can be cut out and the remaining everything can bond directly. This oxygen can bond directly with the carbon. Alright, now how do you name this? Now see, if you know the name of the acid used, if you know the name of the acid used and the alcohol, you can use the same trick, that alcohol will give you methyl here and acid will give you OH. So methyl butanoate. Alright, now let's do another example. So which one should we do now? Let's say ethanoic acid plus butanol. Now try solving this on your own. Let's try this. So ethanoic acid will be written like this, 2 carbons and on 1 carbon COOH is there, hydrogen, hydrogen. Butanol, again, should we write butanol like this? Is there any problem in writing like this? There is no problem in writing like this, but generally, lot of children face confusion in just directly seeing how exactly is water being formed. So for that, I've recommended to you that instead of writing butanol like this, you write OH closer to the acid. So something like this, OH like this, then 4 carbons here. This is also butanol. And what is the benefit of doing this? Your confusion gets cleared. You can directly see that this OH and H are combining together and they are forming H2O as a product. Right? So we can put this in a box. OH and H are gone. So one of the product is H2O. Now, what about the ester? See, if all of this is gone, that means this oxygen will bond with the carbon. That is its only option. So I'll draw the same thing as it is again. See, this oxygen just directly connected with that carbon. This is your ester. Now again, how do we name this? Your alcohol will give you YL, YL, so butyl. And ethanoic acid will give you ethanoate. This is your name of ester. I'm hoping the naming part is clear to all of you. We can revise it once again. I simply gave you the trick that any alcohol or any acid they are given you in any order, whether acid is written first or alcohol is written first, you have to look at the alcohol first. That will give you the prefix. And if it is propanol, you will call it propyl. Butanol, you will call it butyl. Methanol, you will call it methyl. Ethanol, you will call it ethyl. Then what about the suffix? The acid will provide the suffix. So if it is methanoic acid, you can call it methanoate. If it is ethanoic acid, you can say ethanoate. Pentanoic acid, pentanoate. Ethanoic acid, again ethanoate. Combine both the terms, then you will have your ester. Alcohol will give you YL, so propanol, propyl. Oic acid will give you OH. This was the naming point, or you could say the naming trick. Now, one question remains, that if they have given you the structure of an ester and they're not telling you which acid and which alcohol was used, so how do we name it? Let's say something like this is given. I'm writing dash to represent the hydrogens present. Now, how do you name in this scenario where they're not telling you which acid was used, which alcohol was used? See, if the acid and alcohol used were directly shared with you in the question, then you will directly apply the trick. But now only the structure is given and you need to tell what is the name of ester and which acid was used here and which alcohol was used here. This kind of question they can also ask you. And I think there is a one question which I have copy pasted here as well. See, the same question. When alcohols react with carboxylic acids, esters are formed. So, general statement, they're not telling you which alcohol, which acid. Then, the structure of an ester is given and they're asking you name this. And in the second part, again they're saying give the name of the alcohol and carboxylic acid used. So, this kind of question is also asked and the same we are discussing now. So, see. Yeah. So, how do you name this? Now, you need to understand one very important point. You should start from the carbon with the double bond. Now, just think and ask yourself the carbon with the double bond is always present with the acid or the alcohol. The acid generally has carbon double bond oxygen, right? So, you will pick this carbon as your primary carbon and this will be your first carbon that you will number. Now, if you go to the right, is there any carbon present? No, oxygen is present in between, right? So, your main chain will be to the left of the chain here. And why? See, I'm hoping all of you understand that carbon double bond oxygen will be the primary carbon, first carbon you could say, that we are going to number. So, let's say I'm picking this as 1. Now, let's explore both the options. If I go to the right of the chain, carbon is not present, it's oxygen. We cannot number oxygen. We in a carbon chain, we only number carbon, right? So we can't go this way, we will go the other way around. So this will be called second carbon, this will be called third carbon. So this is your main chain. This forms the part of your main chain which will give you the suffix. And I'm hoping all of you remember suffix is given by actually the acid, right? We just discussed here that if ethanoic acid is there, then we will call it ethanoate. If butanoic acid is there, we will call it butanoate. If methanoic acid is there, we will call it methanoate. So this chain here, this will give you the suffix which will also tell you which acid is there. Now you just look at how many carbons are there in that. As much as I can see, there are 3 carbons only. So 3 carbon will be propanoic acid. Then what about the other one which is present on the other side of oxygen, single bonded oxygen, the other side of this one, what about this one? Then this must be alcohol, na? Because acid you have identified already. The remaining part must be alcohol because only these two combined. So 4 carbons, we can call this butanol. Now you have successfully identified that the acid is propanoic acid and alcohol is butanol. Now, how do you name it? Again, use the trick. Butanol, so you can say butyl. Propanoic acid, so you can say propanoate. I'm hoping this makes sense. Let's do another question to make it more clear for you. So something like this, right? Then again, hydrogens are there. We'll just mark dash for hydrogens. Now, structure is given to you and they're again asking what is the name of this ester and what is the acid it is made out of and what is the alcohol it is made out of. Alright, so what do? You look at the most important carbon, that is carbon double bond oxygen, this one. So this carbon is the prime suspect here, you could say. Now, this will be termed as position number 1. Again the same thing, if you go to the right, there is not really a carbon present, there is oxygen, we cannot number oxygen. So that means this chain on the left hand side, this must be the acid wala chain, or you could say this is your carboxylic acid chain. How many carbons? 4. So the acid must be butanoic acid. So your acid is identified. Then what about the other one? Now, pretty much clear already that 3 carbons, so this must be alcohol. So propanol. So the name will be propyl butanoate. Why? Again the same thing. Alcohol will give you the alkyl part. What do I mean by alkyl? So propyl it will be called. And acid will be OAT, so butanoate. Alright, let's do another example. So now something like this is written. How do we name this? Again, do not try to memorize any stuff. Just use the logic that what is our prime suspect here? The prime suspect is this C double bond O carbon. So I will mark this number 1. Now let's explore both the options. If I go to the left in this case, there is not really any carbon present. It's only oxygen. That means we cannot number this. We will have to use the right hand side chain as the main chain. And main chain is responsible for the acid. So 3 carbons in the main chain. That means propanoic acid. Then what about this alone sad carbon? Then this must be from alcohol, right? And if it is only 1 carbon, that means it is methanol. So now again, we have identified the alcohol, it is methanol. We have identified the acid, propanoic acid. Now use the trick that when methanol combines with propanoic acid, what will be the name? Methanol will be written as prefix, so methyl. Propanoic acid will give you propanoate. Question done. Alright, now let's say some other kind of representation. They have written something like this: CH3, CH2, OOC, CH2, CH3. Oh, this looks a little tricky. Is it really tricky? No. Use the points which we just discussed. You look at the carbon which was connected to the double bond oxygen. Now, you might say that I don't really see a carbon double bond oxygen here. There is COO simply means carbon double bond oxygen and oxygen, right? So you look at this carbon, this is the one connected to both the oxygens. That means this is the carbon with C double bond O, right? Now again the same thing. If you try to go to the left in this case, oxygen is there. But if you try to go to the right, you will find carbons. That again tells me that this section is the main chain, and main chain is responsible for giving the suffix in the organic compound. 3 carbons, so propanoic acid. What about the other part then? There are only 2 carbons, then it must be alcohol. That is ethanol. You can call this ethanol. So you have identified the alcohol and the acid being used. Now, if they ask you the name of the ester, what will it be? Ethyl propanoate. Alright, I am hoping all of this is clear. Now, there is just one last type of question remaining. Sometimes they ask you for isomer of the ester. Isomers of the ester. And this is an important question. It's not made up. It has been asked in the past papers already of IGCSE. So, isomers of the ester. Now, you need to understand what isomers are. We will not do it in detail. We will just discuss till the level of esters. Isomers are the molecules with the same molecular formula but different structural formula. So how exactly does this work for esters? Sometimes what happens is, let's say in the exam there is this question where they say that we have propyl butanoate. We have propyl butanoate. Give me 2 isomers of this. Alright, so I'll directly tell you how to tackle this. Conceptually, how exactly does it work? What are isomers? Let's leave that for some other session. Isomers we can discuss later on in detail. But if this question pops up in your exam, how to handle this? If they give you any ester and they say, tell me the 2 or 3 isomers of this, what you need to keep in mind is you first of all sum total carbon atoms. So in this case, prop is here and but is here. That means 7 atoms are there, right? Now, one thing you can solve this very easily is that you increase 1 carbon in alcohol and decrease 1 carbon in acid. What do I mean by this? If it is propyl butanoate, instead of propyl, you can call it butyl. But butanoate, you can write as propanoate. Now, if you will try to total this, again it will come out to be 7 carbon atoms. So this is another isomer. Let's say they're asking you some another isomer. So now you can do the other way around. You can do the other way around. For example, you can bump the acid and decrease the alcohol. So propyl you can write as ethyl and butanoate you can write as pentanoate. This is another isomer. If you want another isomer, you can bump the alcohol one level up. Sorry, the acid one more level up. So something like methyl hexanoate. But this much they generally will not ask you. They generally ask for 2 isomers only. So one very simple recommendation, the acid that you have or the alcohol you have, increase by 1 and decrease the other one by 1 carbon. Right? Let's pick another example. Let's say propyl butanoate. Is it the same example? Oh, yes. I don't know. Maybe I like this combination. Ethyl propanoate. Alright. So again they're asking isomers of this structure. One very simple tip. You look at the alcohol first. There are 2 carbons now. Let's make it 1 carbon first. So methyl. But now you have decreased 1 carbon here. You will have to increase 1 here. So butanoate. This is an isomer of this original structure. Can we name another one? Yes. Earlier you decrease the alcohol, right? Now increase the alcohol. From ethyl you can write it as propyl. And propanoate can be written as butanoate. Are we making a mistake here? Yes, we are. See, we increase the alcohol here, right? So you will have to decrease the acid. Instead of propanoate, it will become ethanoate. We can do one more example just to make it 100% clear for you. Butyl ethanoate. Alright, give me 2 isomers of this. So first increase the alcohol by 1. So you can call it pentyl. Generally they will not ask you pentyl in your syllabus, but you understand the logic. Then you will have to decrease this by 1. So methanoate you can call this. Now you can decrease this alcohol. So you can write it propyl and you can call this propanoate. Now you can also cross check all of this by drawing the general formula and drawing the structure, but it will come out to be the same only. Isomers in detail we will discuss in some other class later on. Alright. Now the theory for esters is done. Let's tackle a few questions. Then the preparation of esters will be done. So first example, see, and these are all past paper questions directly, so it will help you understand. Ethanol reacts with methanoic acid to form the ester. Name the ester. You can directly do this now. Ethyl and methanoate, just as we discussed. Right? Now, draw the structure. So again, use the same tip that I gave you. You write the acid first and write the alcohol later on. So let's draw it directly. Methanoic acid looks like this. And you write the alcohol. Do we write it like this? Should you write CH3, CH2OH? You can, but it will not again help you in identifying that how H2O is getting cut. So instead, you can write OH closer here, then CH2, then CH3. Then you cut out this here, and now your ester will be this. See, this is gone, so oxygen will combine with this carbon. And make sure to note down hydrogens there in your actual exam. Do not be a lazy person like me. Okay? This question, see. Give the letters of two compounds that can react with each other to form ester. Now, I'm hoping you recall that esters are made from acid and alcohol. So you can see acid here. This is an acid. This is also an acid. And alcohol is D. This. So you can say A and D or A and E. You need one acid, one alcohol. Done. This question is the most important one. We will do this in the end. Now, this one, see. Here, they're not telling you which acid and which alcohol is getting used, but we have also done this kind of question. What do? You look at the primary suspect, which is carbon double bond to oxygen. Now, we mark this as number 1. If you go to the right, there is oxygen. So, you can't number this. That means the left part of the chain is acid. How many carbons are there? 4. So, that will be butanoate. Right? Because butanoic acid will give you butanoate. What about these two carbons? These must be from the alcohol then. So ethanol will be the alcohol. But in the name, you will write it as ethyl. Now they're asking the alcohol. We have already identified this. Ethanol and butanoic acid. I'm hoping this makes sense. Another question. Now they have written it in formula form. We've also done this question. We have also discussed this as an example, right? So what do? You look at this carbon. Let's zoom it in. You look at this carbon. This is your first carbon. Now again the same thing. If you try to go to the right, oxygen is present. You cannot number oxygen. That means the chain on the left is your primary chain. So 4 carbons, that means butanoic acid. What about the alcohol? Then this single carbon must be the alcohol. So methanol. How do you name the ester? The same logic. It will be methyl butanoate. Now they're asking the name of carboxylic acid and alcohol. We have already done this. Carboxylic acid is butanoic acid and the alcohol is methanol. Done. Now, draw the structure of the carboxylic acid and the ester which both contain 2 carbon atoms. Interesting. So they're asking you an carboxylic acid with 2 carbon atoms, that is ethanoic acid, right? How do we draw? You put 2 carbons, OOH, then hydrogen, hydrogen, hydrogen. Done. Ester, wait, might be reading the question wrong. So draw the structure of the carboxylic acid and the ester which both contain 2 carbon atoms. So the carboxylic acid that contains 2 carbon atoms is this, and the ester that will contain 2 carbon atoms will be methyl methanoate. Only this is a possibility, right? Just think about it. They're asking you an ester which contains 2 atoms only. Then the only possibility is methyl methanoate. Right? So how do you draw methyl methanoate? You can write it like this. Now, you might be getting confused with this. See, methyl methanoate must be made from methanol and methanoic acid. Right? And how does methanoic acid look? Methanoic acid is this. How to write methanol? So OH with a CH3. Now you cut OH and H from here. This is gone. What are we left with? HCOO, O, C, H, H, H. The same thing I've written here. I'm hoping this makes sense. Yeah, good question. So this is the last question, then we will jump to the complete question. So they're saying other esters not in the list have the same molecular formula as propyl propanoate but different structures. Now understand this. We have also discussed this type of question. They're talking about isomers here. Same molecular formula but different structures. State the term. This is structural isomers. The proper term is structural isomers. Now, name two esters with the same molecular formula as propyl propanoate. What do? You increase the alcohol by one carbon. So instead of propyl, you can write butyl. And instead of propanoate, you will have to decrease this by one to keep the total carbon same, right? So you can call this ethanoate. Now you can do the other way around as well. You can decrease the alcohol. So you can call this ethyl, and propanoate, you can write butanoate. I'm hoping this is making sense to you, but in case there is any doubts, do let me know. So ethyl butanoate. You could say it's a smart way of handling this, that we need to keep the total atom same, right? Currently there is 3 here, there is 3 here. So what I did here is that you decrease this by 1. So increase this by 1. Total needs to be the same. So ethyl butanoate. Oh, where is it all gone? Yeah, I'm hoping all of this makes sense. Now, the last question, and with that question, we will be done with the esters. These are all the kind of questions they ask you. Alright, now let's see the last question. So, state the name given to a family of organic compounds with similar chemical properties. This is called your homologous series. Explain why members of a homologous series. This we can skip later on. Currently, let's focus on the esters questions. State the name. Yeah, let's start from here. Determine the value of N in butyl propanoate. And N means the total number of carbons. But is 4, prop is 3. So 7 is the answer here. Alright. All 4 esters are liquids at room temperature. Name the technique used to separate. You can use fractional distillation for this. Now, this question. All 4 esters, you need to understand this carefully, yeah? All 4 esters can be made by reacting different alcohols with the same substance. What are the 4 esters? They must be written above. See, you notice one common thing here. This is alcohol, alcohol part, different. But all the OH molecules are same. Propanoate, 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 propanoate. That means the acid used is same here. And they're saying the same thing. Different alcohols they're using with the same substance. What is the same substance? This is your carboxylic acid. Right? And you will have to name this specifically. Come on, you can do this now, right? Propanoate, so this is propanoic acid. The name will be propanoic acid. Structure, draw 3 carbons, O, O, H, hydrogen, hydrogen, hydrogen. Yeah, done. Now, name the alcohol used to make methyl propanoate. We have discussed this already, that this is your prefix methyl. So the name will be methanol. And now we are done with all the kinds of questions. I'll suggest that if you're still confused in the topic, watch the video once again. But if still not clear, do let me know.